Greetings, Earth enthusiasts. If you ever wondered about the incredible perspectives our planet has to offer from high above, you're in the right place. I am Dr. Clive Coetzee, and I'm thrilled to be your guide on this captivating journey into the world of remote sensing. Welcome. And please remember to like, subscribe to, and share this video. Thank you.
Welcome back. We are working with object-based image classification. Remember, we've been working for the last, I don't know how many videos on image classifications, where we looked at their spectral signatures and tried to put them together to say this is water, this is this, whatever. Okay, so yeah, so the object-based image classification is a little bit different in that, first of all, it works with vectors. So that's interesting, because the pixel-based image classification works with rasters. So here we're working to a large degree in vector format. Obviously, we can, once we've done the classification, we can convert that vector into raster format to compare accuracy, etc., etc. But for now, just take note that most of the work is done in the vectors, and there's a couple of steps. And one of the unique steps in this, or the important steps in this, is the segmentation. So we spent some time on the segmentation, and then once we've got the segmentation done, then the process of creating the statistics for each of those segments, and then once we've got the statistics for each of those segments, then we can actually do the classification. So there's a couple of steps, and importantly, we're using the OTB or field toolbox for this in the main. And there's some videos and stuff how you can download the toolbox. If you don't know, just let me know. I can take you through the process of installing the toolbox in QGIS. But before I proceed, let me just please ask for you to like, subscribe to the channel. It means a lot. Your support means a lot. So please like, subscribe. Let's get those numbers up. And also feel free to like me on Facebook. We can chat on there as well. So yeah, if you won't mind, please press those buttons, send, share, and stay up to date. And your messages are always more than welcome. Okay, so just a reminder, we've got our stack raster. This is Sentinel bands 0, 1, 2, 3, 4, 5, etc., etc. So there's our stack raster. So this is bands 2, 3, and 4 true color. Presentation of it here. You can see there's obviously all these what they call segments, and so that's the first thing we do, is we generate the segments. So you can see there, you can see it groups these features, these collections, similar collections, similar features. It groups it and creates these segments. And as I said, we use the OTB, and the segmentation there. We use this segmentation function there. So there we go. In this case, we are working with 8,782 segments. So it takes my image and it generated 8,872 segments. You can see there. It's almost like unsupervised classification, in that it creates these groups, these groups that are similar. You can see there's a nice one there. That have similar features where there's textures, structure, etc. So image segmentation. Okay. So once we've got the segmentation done, now we need to generate the statistics for each segment, meaning the stacked raster statistics for each of these segments. So what is the band 1 statistics for each segment? What is the band 2 statistics for each segment? What is the band 3 statistics for each segment? So when we talk about the segments, it's the number of pixels within each sector. Like is each segment. So let's, for example, look in there. So you can see there's 1, 2, 3, 4, 5, 6, 7, 8, etc. Let's take this much. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 19, 20, 21, 22, 23, 24, 25, 26, 27. There's 28 segments, pixels in this. Remember, this is, I think, 10 square meters. It's a spatial resolution, if I'm correct. Landsat, yeah, 10. Or is it 20? Some bands are 10, some bands are 20, but I think band 2 and 3 are 10. You can look it up, but I'm almost certain it's 10. So there's what's it, 28 pixels within. And so what they do is look at these 28 pixels. What is their band 1 average? What is their band 1 mean? What is the band 1 minimum and the band 2 maximum? The band 1 maximum. I think that's the 4 statistics. The mean, or it's not the median, mean, standard deviation, min, max. That's the 4 statistics. Okay, so remember there's 4 pixels and for each band. And let's say for band 1, each of these pixels will have, so let's quickly go there. So where's band 1? Let's quickly have a look there. There's band 1. Let's take that. So there's band 1. You can't actually see it, but obviously there's 28 bands, 28 pixels, and each of these pixels has a different value. So we have what's the mean of the 28 values, what is the standard deviation of these 28 values, what is the minimum pixel value, what is the maximum pixel value. So I hope that makes sense. So that's what we've done. That's what we're going to do now, separate. After we've done the segmentation, we use the zonal statistics. Zonal statistics, there we go. We use zonal statistics, and this is what we have then. You see there is the 8,800 and whatever pixels, segments. If we right click the open attribute table, you'll see that it will have the count. So in that segment 8815, there's 1 pixel. 8812, there's 31 pixels. 8811, there's 26 pixels, etc. So let's have a look and see. These ones have only 1, and then it's 21 pixels. Which one has the most? 7782, segment 7782. Then it's got 223. If I do this, let's see if it shows. There we go. Come on. That is segment 7782, and it's got 223 pixels. 223 pixels. Okay, so, and then deselect, and then the mean of band 1 is 0.04, standard deviation of band 0, the minimum for band 0, the maximum of this 223 pixels. Mean for band 1, standard deviation for band 1, minimum, maximum. Okay, so these are all the statistics, and to band 11. Okay, so let's just quickly make sure. If we go into stack raster, in that case there was 11 bands. So let's have a look and see properties. We go there. There's band 1, 2, 3, 4, 5, 6, 7, 8, 9, and 11. It doesn't obviously do band 12. Band 12, I think, is some other. I'm not sure what band 12 is, but it doesn't capture it for band 12. Not sure why, but yeah. Sorry. Let's go back. It's got properties. It's got band 0, so that is 12. So it captures them all. Because if you look at the statistics, go to open app table, it starts at 0 and not 1. So there's just a basic presentation of the numbers. Okay, so once we've done this, now we need to go back into our training, and we're using our training file that we've used for the pixel-based image classifications. Same training file, nothing different in vector format. So what we want to now do is generate this, or identify the segments that relates to these trainings polygons. So for example, these ones, obviously they've got nothing to do with these training polygons. But the segments that is related to this, we want to isolate. And we want to generate the statistics for, we want to capture only the statistics, the zonal statistics for these segments that's related to my training samples. And so we do the join function, join by location. We use that function, and this is what we get ultimately. So let's take that away. You can see there, these are the segments. So all of these segments as it relates to this specific training sample. These are the segments as it relates to these training samples. So you'll see these segments that's got nothing to do with the training samples are now excluded. They're not part of it. And also each of these segments obviously will have the various layer information, band information, sorry. So if we open that one, you'll see there we have 3, 4, 5 segments, and then obviously there's all the band statistics for only this 3, 4, 5. So these training samples, training polygons, they are related to or relevant to 3, 4, 5. Remember, there's 8,800. So what's it? That's percentage is 0.00 something. Let's just call it 8,800. And then we're going to divide it by, or say 3, 4, 5 divided by 8, call it 8,800. So that's 0.04%. So that represents 0.04% of the total segments that we've done using our segmentation. Okay. So these are important steps that we've done. This is where we want to get to. Okay. So this is important. So now, once we've got this now, let's say this is our foundations and some of the walls. Now we can actually start the classification process. And the classification process also consists of two. The one is to create a model, and then the next one is to actually do the classification. So we're going to go to our OTB classification, and we're going to go to learning. And within learning, we're going to find train vector classifier. Okay, so it is OTB, Referral Toolbox, under learning, and learning is train vector classifier. And then once we've done that, then we're going to use the image classifier. So that's the two steps that we're going to do. Train vector classifier. Okay. And the other one is image classifier, vector classifier, sorry, vector classifier, not image, vector. Image is a raster. Okay, so train vector and vector classifier. So that's what we're going to do next. So we're going to do this in two separate videos. Okay, so let's go into train vector classifier. So if we open that, there is our input window. So in here, we're going to basically put our, that joint layer, we're going to add in here. Okay, so this is the joint layer, There we go. Zonal statistics. Now what we call it, segmentation 3 joint layer. So let's go segmentation 3 joint layer. Now, if we had an XML image, we can upload that, but we don't have it, so don't stress about it. It's optional. So if you see there, we don't have it. So we're not going to what layer index. We're not going to be concerned about that. Okay. Now the important stuff, in my mind anyway, important stuff starts. Okay. So in here, we're going to select which of these features do we want to include in our model. Okay. Which of these statistics, sorry, not features, which of these statistics do we want to include in our model? Okay. Now, the count, is that relevant? Is it going to make any difference in the classification? No, most probably not. So do we need to include it? I'm not going to include it. It's not going to contribute, because what we're interested is the pixel values. The the spectral signatures of each segment. So now, are we going to choose all 4 statistics per band, or are we only include certain statistics for each band? Now that is something of a bit of a trial and error. I don't know. It's really up to you. And again, you'll have to play around with this. Okay, but it's very, very time consuming. I think at a minimum, or the 2 that we should look at is the mean and the standard deviation. Or at a minimum, only the mean. I see in many cases people use both the mean and standard deviation. Some people only use the mean. I haven't seen really people using the minimum or the maximum. Remember, what you want again is uniqueness. Remember, always this important word, uniqueness, when you do image classification. What shall we do? Eeny, meeny, miny, mo. Would that be a proper way of making a selection? I don't know. Okay, but for now, let's look. When you run this, you're not going to have an idea how accurate or how wrong you are. It's only when you actually do the classification when you'll know. But for now, let's just use the means. Okay, so let's just use the means. Make sure you select. And again, you don't have to do all the bands, ne? You can only do certain bands. So you don't have to do all of them. But for now, I'm just going to do all of them because, again, it's about uniqueness. But again, this would become something of a trial and error. So there's all 12 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. Mean. And again, as I said, what you ideally would want to do, and maybe this is something I can do for the future, is to use the principal component analysis, because they will identify, the bands that we have to include. So maybe, yeah. So that could be something that we can look at in the future, is to say, okay. You want to under-specify or over-specify, and I said we can use the principal component method to identify the bands that contributes, let's say 99% to it. But for now, let's stick with all the bands. Okay, so that's important. Remember, when we do the actual classification, we're going to use the same statistics. We're not going to use different statistics here. So always remember your choice. Validation vector data, if we have, you can include it. If we don't leave it. Optional. Fields containing class integer. And that is now obviously the ID. Okay, because remember, if I go to my training, if I open the attribute table, you see there the classes is, and it's integer, and not the word, the text, it's integer, so that's under ID. Okay, so we're going to keep the ID and stuff. So just please take note of that. Yeah, so please take note, important. Again, so this is the one that we add in here is the zonal layer. Okay, the zoned layer that we've just created, meaning that segments that is relevant to our training samples. Okay, with the band statistics. And these are the statistics that we want to use in the model to do the image classification. And then field containing the class and label of the supervision, meaning what they here say is the label or the column in that vector or in that attribute table that talks to the classes of the classification classes, which is the ID. Verbose mode, some people include it, some people exclude it. Let's exclude it. Now, here comes the options, and there's lots of them. And again, this can keep you busy for a long day. So, classifier to use for the training. Let's see, there's the LIPS, the boost, DT, artificial neural network, Baynes, random forest, K-nearest, SARC, RF, and SARC KM. Now, this becomes tricky in that it's very difficult, and you'll have to do trial by error here. Which is the best? Which is the worst? It depends on the image, the segmentation, the this and that. There's no hard or fast rule to say this will be the best, that will be the worst, etc. That's going to be totally to your discretion, which one you want to use, etc., etc. And you're going to play around. And then to make matters worse, in inverted commas, is that each of these have further options. So the LIPS-M, you can do a linear, RBF, poly, and segment. And then the SM support vector machine mode, you see, I don't know, to be very honest, what some of these things mean. Theoretically, I presume they should make a difference. Whether they make a difference or not, I don't know. But yeah, take that into account. So where do we start? Which one we gonna do? So if we choose LIPS-M, linear. If we choose boost, real, discrete, logic, gentle, so it's going to be obviously real. Our values are in real numbers. Then you can see there's weight, etc. So I'm just going to leave these default values. If we're going to do DT, see this. If we're going to use artificial neural networks, back and that. If we're going to do Bayes, random seed, output model basis, it's a random forest, trees, sample, we can here as neighbors, number of neighbors, SARC, and SARC. You'll see there's all sorts of parameters that comes with these ones. Let's do random forest, just for interest sake. And again, we can play around with these parameters now. That's totally up to you. You see, there's a whole lot of these parameters. Now, I would assume, as I said, theoretically, they should make a difference. Whether they actually make a difference or not, who knows? I have no idea. Well, we'll have to play around with it. But as I said, this can keep you busy for weeks and weeks and weeks on end. And as I said, there's no hard and fast rule. It totally depends on your region of interest, the actual data image, the segments. There's a whole lot of things that plays into this. Okay, so let's leave it as is. But as I said, you'll have to play around with it. So, okay, so let's go output model. And we're going to save it. And we're going to say it segmentation 3. And it's going to be random forest. I was going to do dot. Remember the achtervoegsel? I don't know, I forgot. That thing there, it's called model, okay? Segmentation, let's go save. Is there anything else? I'm just going to say default. Underscore. Let's lose the 5 and the 10. 5 underscore 10. Then we know it's a random forest. Depth of the tree is 5. Number of sample is 5. We're not going to termination of criteria. We're not going to look at the clusters. Then 0. Size of random selected subset. Maximum number of trees. I think that could be something as we're going to make it 100. And sufficient, I'm going to leave that. So the ones that we potentially can change is depth of it, minimum number of samples, and the number of trees. And remember the achtervoegsel, this thing there, the type file that we're going to save it, dot model. Okay, so let's run it. And it's done. Okay. It says there for classic one, there is 997, 107. Remember, this is going to add up to our, what's it, number 3 or 4, what's it, 3 something something number. Um, what is it? I can't remember what the 345. So this must add up to 345. These ones. So there's 6. There's in 6. What is 6? ID 6 again. ID 6 is sand. So for sand, there's 19. 5. Biggest is 3. What is 3 again? Open attribute table. 3 is mountain. That's weird. Can't be that. Anyway, that it is. So if we want to have a look and see how that file looks like, where it is, let me just quickly image classification. Come on, image classification. There it sits. Now, as I said, you can't really open it. Let's say if I open this in Notepad, there it is. There's my model. There's the whole model that we've generated, as I said. You can see there's all the regression. There's the 5 and the 10, the number of trees, the parameters, or that we haven't done. Again, not sure what all these things mean, but anyway, that's the model itself. So so we're gonna run that. So let's quickly say if we do um, let's do a boost. Boost real. Okay, so let's do a boost model. Boost. And we're gonna say it is real, and it's gonna be also 100. And that we leave the same. Let's have a look and see. Boost, segmentation, real boost. And we're gonna keep all the other ones the same. And we're gonna say run. And there it sits. So let's quickly have a look and see if we see any difference between the two. Okay, so I'm gonna refresh it. So let's click that one. Open in Notepad. It looks like that. And let's see if we open this one. Editing. So that's nodes. Okay, so that's just the same stuff. Okay, so it's that's depth. Where is the other one now? So let's quickly close some of these ones. Classification. Segmentation. So why is it not opening it or opening the other? Sorry, I just want to quickly close some of these so that it becomes easier to open. Okay, so that's the raster, that's that model there. And then, so why is it not opening so let's say edit in Notepad. There we go. So that's the difference. Okay, so there's the boost. So there's the random forest. You'll see nodes, depth 2, value, split, depth 1, value 2, depth 2. Let's have a boost. Depth 0, value 1.8. Depth value 2. Anyway, so the boost it's quite, that's line 34, and the random forest is line 36. So the two models are not that, oh, I don't know. Okay, so anyway, so there's the two models. We can do, let's do DT 10, 10. So let's do a DT boost, and let's do a DT, and then it's going to be 10 and 10. That all there. And we're going to run that one. and so forth. I'm just playing around with this. We can, as I said, let's say if we maximum depth of the tree, we can play around and see how it changes the model and stuff. But for now, I think you get the idea, or I hope you're getting the idea that um, what we have to do now. And since, as I said, once we've done this, then we're going to do the vector classifier. Okay, but I said for now you're not going to know whether which one is the worst or which one is the best until such time as you do the vector classifier. Only then will you get an idea of the accuracy of each of these different models here. But as I said, for now, just understand that there's a whole lot of these ones. And just by using the training, we're not going to have understanding of the accuracy or the relevance of each one. It's only when you actually do, so let's do KNN, when you actually do the classification, KNN, K nearest neighbors, and number of neighbors is 32. So that's it, and we're going to run it. So we've done how many now? 4 of them? So there's 1, 2, 3, 4. So we've done 4, and we've kept the default settings. We just changed the models, but we've kept the default settings. So in the next video, what we're going to do is we're going to run these 4 models in the classification, and then have a look and see how they compare. Yeah, so let's close it. So as I said, you'll see there's nothing here. So nothing has been added to the layers panel, but it's been added to the folder. So when we do classifier, remember there's going to be now your input vector. So here we're going to go back to the segments of the entire area. So it will be zonal statistics. So it's not the joint layer. We're looking for the entire area. So we're looking for this one, which is because we want to classify the entire area. So we want to classify each of these segments now. And then they're going to ask you for the model. And you'll see there, we're going to select the models. And then it's going to classify. So 4 steps involved. Pre the accuracy assessment. There's 4 steps involved, all in the Orfeo toolbox. Okay, so that is step number 3, i.e. also video number 3. Okay, so please follow along. If you find some interesting nuances or interesting things that I may have missed, or let me know. It's always surprise. There's always many surprises and interesting stuff. I found that, as I said, theoretically, a lot of these parameters should make a difference, but in most cases, I can't see these differences. Obviously, in the main changes, yes, like the type of model, there's big differences. But in the small details, it doesn't make much of a big difference. But as I said, that's wholly dependent, I think, from based on your region of interest, etc., etc. Yeah, so just as a final plea, please like, subscribe, share these videos. Let them run in the background, man. It doesn't cost you anything. Let it just run. It does help a lot. So yeah, takes a lot of effort to make these videos. I am thankful for your support, but yeah, we can grow it together. So with that said, I'll see you on the other side.